Today's lecture is about the NumPy functions. NumPy can generate one-dimensional and two-dimensional arrays for vectors and matrix operations, and it can be used for data processing with arrays. We quickly calculate complete multi-dimensional matrices and random number generation. So when you want to use NumPy function, you can use import NumPy as NP. Over here, import NumPy as NP, and you will use this NP for subsequent use. And you can use NumPy array to create a matrix as shown in the figure. So we can directly type it in the as you can see, when you type the code A, you can define A array and B array. And here is we use a variable resource1 to get the result of A plus B. And so you can print the result over here. So it is 6, 9, 12. It's 2, 4, 6, 7. So you can give it a test. So I'll give you maybe 3 minutes to exercise. And you can see the code that I typed on screen. Test tool on the Moodle, so you can open the file. So I will continue the next step. So you can also use, you can also create a two-dimensional matrix and then add plus 2 of them to enter the result. So when you create a two-dimensional matches, you need to use outside of outside the two matches. You need to use a comma to separate, and also use this to hold it together to make it become a new two-dimensional matches. And you can take some exercise. And I will show the code on screen. So let's move on to the next function. So you can use point key to convert the matrix, just like this. A, if your matrix name is use A, so you can use A point key to convert your matrix. And we will use this function in today's exercise. So when you use A point key, you can see over here is the original matrix, and this is the transform matrix. So you can make it a chart. So let's move on to the next function. And you can use a point dot, to calculate the dot product. And you can use numpy point inner to calculate the inner product. And you can use the numpy outer to calculate the outer product. you can see, as you can see over here, I create a two-dimensional matrix over here, and I use a variable called A to compare this two-dimensional matrix. And then I use a variable C to get the three-dimensional matrix. And so I use result 1 to get the A dot product C. So you can see the result over here. And I use the result 2 to get the inner product. So you can see the result over here. And so I use the result 3 to get the result of the outer product. So you can see over here, this is the result. Okay, and then choose. So you can take it and try. So you can create a matrix by using NumPy arrange. And in NumPy arrange, you need to input the start and end number of the range and the spaces between the range numbers and also the numbers type. So if you didn't set the start number, the default is 0. And if you when you set the start number, it is excluding the value entered by the start. And if you didn't set the type of the number, it will the default is is the type of the input data. If you input 1, you can it will be all the number will be integer. So over here, I create a variable D to get the NumPy arrangement. And the start point is 0.1 and the end point is 8. So it will create a matrix between 0.1 and 8. And the spaces between each number is 1.2. And I set all the number type is float. So you can see over here, it create a matrix over here. So you can take a try. And I think I will give you maybe 7 to 8 minutes for you guys to take the exercise. I think everyone is done the exercise, so let's move on to the next function. So next function is called line space, and it is similar to arrange. You need to input the range of the start value and the start value. And you also need to set the number of the samples of the sequence. And the default is 50. And you need to set the endpoint, so when the value is true, the value of start is included in the sequence. And the default is true. And you also need to set the rest step. If it is true, the spacing is displayed in the sequence. So you can see over here, we set the range of the array is 1 to 10. So it is 1 to 10. 1 to 10. And the space is 10. So the endpoint is false. And you set the rest static too, so it will show the spacing over here. At the end of the array. So you can take a try. So let's move on to the next function. Now you can create a matrix in the log space with NumPy function. You need to set the start point, and number of samples of the sequence. And you can also set the endpoint value. When it is true, the value of stop is included in the sequence. And you can set the base of logarithm log. So you can see the result here. So you set the sequence between 0 to 1, and you set the start point of 0, and start point is 1. And the number of samples of the sequence is 10. So there are 10 numbers over here. And the base is 2. So you can take it a try. So let's move on to the next function. It is called NumPy slices. So you can cut the array in sequence A from the first step. So you can set the slicing rate. For example, if you set A and 1 column 5 is to cut from group 1 to group 5. as you can see the result over here, the complete set rate is 1, 2, 3, 4, 5, and 4, 5, 6. And when you set the one color and nothing set, not number over here, it means you can count from the first array to the end. So you will count. So I will give you a little bit time to make a chart. So let's move on to the next function. It is called NumPy index, and arrays can be indexes using the size function. You can set the start index and the end index and the interval. So you can see I create an original sequence called variable A, and I use S variable to size the array A. So over here is original sequence, and the index sequence is 2, 4, 6. Because over here I start from 2, and at the end is 7. And the interval is 2. So it will 2, 4, and 7. 2, 4, and 6. So you can take a track. So let's move on to the next function. So it is called NumPy coordinate matrix. You can use matchsplit to convert coordinate matrix. Over here you can see we can set to one-dimensional matrix, and we use NumPy matchsplit to make it into a coordinate matrix. And then we can use matplotlib, which is the library we teach all of you last week, so you can show it on the screen. So you can see the result, plot result over here. And I'll give you limited time to take a try. So let's move on to the next function. There are some of the next functions in the NumPy library, and such as sine and cosine, and also the rounding function, such as NumPy floor, which is round down the array, and NumPy cell, which is round up the array, and also the NumPy around. And A is specifies the number of decimal places rounded by the array and decimals. There are also some simple math calculations, such as add, subtract, multiply, and divided, sum of power or mode, which is prepare the remainder of dividing A and B arrays. You can also use NumPy remainder. So you can combine application of NumPy and MATLAB library. And I will show you in the code. So you can see over here. You can set the figure and set the axis and use the NumPy line space and use the calculation, some of the math function. And then finally you can use plus 3D plot to plot out the result. And you can take a try. So let's move on to the final function. You can combine application of MeshGrid and MATLAB library. And over here you can define the MeshGrid form coordinates and the z-axis relationship. So you can see over here, there is S range and Y range. You use MeshGrid to transfer it into coordinate meshes. And then you use Z over here, you use the NumPy log next function to create a Z variable. And then finally you use plot surface to plot out the result. And you can give it a try. background exercise. So this exercise you can try when you go back home. And this is end of today's courses. It is about using mass function. So first of all, you can define a mass function and sample the space at n different positions. For example, n equals to 25. And the sampling point coordinates could be following just like this. And evaluate the function values at all these sample points shown below. For example, the sample point is 4, 4, so you put it into the functions and calculate the result. And the superscript indicates the index of experience n equals to 1 to n. And we can use the following methods to build a regression model. A is just like this, and X and B. And putting them together, X equals to B. But we cannot directly get S by X minus B because A is not a square matrix. So we can use the following methods called least square approximation to determine X. So the function is over here. And at the end, the regression model is obtained by following function. And you can compare to the original function and observe how accurate the model is. And also you can try a different function. So this is today's homework. And when you finish, you can upload to the Moodle.